And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. Today we'll be talking about the degradation of sunspots 2806 and 2807, a small cosmology segment about the Milky Way galactic core, and a volcanic uptick. Yeah, Pinatubo has had its alert level raised. First we're looking at the sun. Here it is in the solar intensity gram from the SDO. And you can see sunspots 2806 and 2807 down there in the southern hemisphere. This is 2806, this is 2807. They're both still beta class sunspots, but they have shrunk and degraded a bit over the past 24 hours. There is still some significant likelihood for some more solar flaring, but not major solar flares. As the sunspots shrink, so does their likelihood to produce large flares. So here is a multiple wavelength view. You're looking at 211, 304, and 171 angstroms, and I would note that 171 is blue here instead of gold, and 211 is green instead of purple. So that's the composite image there. 304 angstroms is still red. And we have reduced the likelihood for coronal mass ejections. We've lowered the watch, so our patrons would already be aware of that. We've reduced the coronal mass ejection watch. Here's a full disk view in 171 angstroms by itself, back to the gold color that our regular viewers are plenty used to. And if you are a regular viewer of the channel, please leave us a comment and let us know why you view the daily space weather videos. Next, looking at a full disk view in just ionized helium by itself, it's 304 angstroms. Pretty weak levels of solar activity here. Again, 2 beta-class sunspots in the southern hemisphere, but they're quite small and they've shrunk since yesterday. Here's a close-up of the southern hemisphere in magnetogram. And they've largely remained stable here. Again, you can see a little bit of degradation there. And these are beta-class sunspots, meaning that we've got 2 opposite polarity umbrae there. You've got a South Pole umbra in the lead and a North Pole umbra in the trail on both of those sunspots. And that's what makes them a beta class. Beta class sunspots are more likely to produce solar flaring than alpha class sunspots, where there's only 1 polarity umbra. Next, we've got a diagram of the solar system. Here's where stuff is now. It's a gibbous waning. There's where things will be in a week. It's a crescent waning, about a day from the new moon, as Venus makes its way around to the far side of the sun. Here's a star chart. I use in-the-sky.org for mine. Put in your location if you want to make a star chart for yourself. And if you're up before dawn and you have a clear sky, you may see the moon and indeed Saturn rising ahead of the sun. And next, I'd like to talk briefly about the 10.7 centimeter radial flux. I know I've said repeatedly that it's in a place that it isn't in. So let me clarify. The 10.7 centimeter radial flux emanates from the upper chromosphere and the lower corona. Just this small area right about here, folks. I know I've said repeatedly that the 10.7 centimeter radial flux comes from the outer corona, and that's actually where the 245 megahertz radial flux is. And the reason I bring that up is because I know I've said it incorrectly. And so this is my correction. If you've heard me say the 10.7 comes from the upper corona, it's the upper chromosphere and the lower corona. The 245 megahertz radial flux comes from the upper corona. So that's just a little bit of clarification there. And our patrons would already know that we saw a 13-minute 245 megahertz radial pulse last night, and that's why we're bringing it up, because I realized that I made a mistake. And in science, when you're wrong, what you do is you admit your mistake and you do a retraction or a correction or whatever, and then you move on with life. You don't double down and try to gaslight people. So anyway, the current state of the 10.7 centimeter radial flux is at 74. So 74 solar flux units. And to put that in context, here is a 1-year chart of it. And you can find that chart on Solon.info. This is the black line here. That's the 10.7 centimeter radial flux, again at 74. So pretty weak levels there, and no surprise it hasn't come up more as those sunspots have degraded instead of grown. So this red line down here, that's the sunspot number. And we see more geomagnetic unrest forecasts. And in fact, we actually see a geomagnetic storm forecasted here for the earliest hours of March 6th. So Saturday, we are expecting to see a small geomagnetic storm condition peaking just around midnight to 3 a.m. Universal Time. And our patrons have been receiving lots of alerts lately, as we've seen lots of periods of things like geomagnetic unrest. Let's talk volcanoes. As Etna is erupting once again, and also Pinatubo, which is the largest volcanic eruption of my lifetime, has had its alert level raised. So here's Etna. It's producing a 20,000-foot ash plume as it continues to explode. Krusuvik actually I think it's Krusuvik in southwestern Iceland has had seismicity increasing. You may have already been aware of this. Lots of earthquakes showing up around southwestern Iceland. Although a sharp peak in tremors was detected at 14:20 local time yesterday and has decreased at a continued rate. So it looks like the seismicity may have peaked. There have been over 18,000 earthquakes since the seismic activity started on Iceland. Suwanosejima in the Ryukyu Islands exploded, volcanic ash cloud unknown. And there's Pinatubo. Pinatubo, having erupted in epic fashion in 1991, actually caused the entire planet to lose some temperature. Yeah, volcanoes are a global cooling factor, especially when they produce stratospheric level eruptions. So we see an increase here in carbon dioxide at Pinatubo there. And since 20th of January 2021, there have been 1,722 imperceptible earthquakes reported by Philippine Volcanoes Pinatubo Volcano Network. So Pinatubo having its alert level raised from 0 to 1. Mild unrest. Dacono, flight level 050, it's a 5,000-foot ash plume as it explodes. Popocatépetl exploding as well, 20,000-foot ash plume there. Pacaya has dissipated its volcanic ash. Fuego, which is also in Guatemala, like Pacaya, is exploding, producing a 15,000-foot ash plume, and continuous emissions once again from Sabancaya are a reminder to not attempt to pole vault the caldera. Next we'll do earthquakes, and the largest of the past 24 happened almost 24 hours ago at the time we're making the video here. It was a 6.3 in Greece, and this one probably caused some damage. It was quite close to this town, the town of Ternavos. The town of Ternavos, pretty close to that 6.3 magnitude quake taking place there in those mountains. So while it was an unpopulated area, there was a populated area pretty close by. Let's go up the list of the past 24 hours. So you see a bunch of aftershocks there not showing, the main quake not showing up on the list now because it was just about 24 hours from when we made the video. So in any case, you'll see a lot of aftershocks there. Here's a deep quake near the Mariana Islands there, sort of in between Australia and Japan. It was at 219 kilometers depth and a 5.0 magnitude. Anyway, there's the list. Here's a location of that, one of those aftershocks here near Ternavos. And this town here would be the main town that would have been affected by that quake. Let's hope it wasn't too much destruction. A 6.3 magnitude is plenty of shaking to do some damage. Also a deep quake there at Indonesia. Let's continue up the list here. We don't want the video to be too long. Here's another deep quake in western South America at Chile. It's a 4.4 magnitude, just over 100 kilometers depth. A deep quake in Russia. That one actually out in the western Pacific there, south of the Kamchatka Peninsula. Here's another deep quake at the Solomon Islands, a 4.9 magnitude at over 500 kilometers depth. And a couple of small deep quakes in southern Alaska as well. By the way, this was not a smAsho stream. We usually stream live to Twitch, and there were some technical difficulties today. So if you typically view the videos on Twitch, this is a reason to subscribe to YouTube, because this would be a YouTube exclusive. It will also appear on BitChute. And thanks to our new subscribers, loyal subscribers, etc. over on YouTube. Thanks, YouTube viewers. By the way, I would invite you all to watch the Sky Scholar channel. There are some great videos here about the likelihood that stars are made of condensed matter, not highly diffuse gaseous plasmas. So perhaps have a look at Dr. Robitaille's channel, Sky Scholar. If you haven't checked it out, please do. You will perhaps understand things that you never even considered about heliophysics. Our videos also do appear on BitChute. It's bitchute.com/smAshomash. And here's today's cosmology segment. It's going to actually be integrated into today's daily space weather video. And we typically do cosmology segments in the daily space weather videos. Sometimes we put up clips, sometimes not. There is a playlist, youtube.com/smAshomash/playlists. Includes one for cosmology segments. Let's talk about the core of the Milky Way galaxy. So here's sort of a close-up of the core of the Milky Way galaxy. And what's going on here? Well, what's going on here is at least 38 massive hot stars are orbiting the galactic core, known as Sagittarius A star, in an epically fast fashion. Some of these stars are moving at speeds comparable to the solar wind, at hundreds of kilometers per second. So there is the orbital situation happening. You can see S2, S14. Look at the highly eccentric orbit of S14. Look at the more circular orbit of S13. Look at S2 and S1 and S12 and S8. And how about S17? What about S31? What about S33? And what I'm showing you here, folks, the reason that I'm showing you this is because the Milky Way galaxy at the core is not affecting the sun the way that the sun is affecting the Earth. Let me just repeat that. The galaxy is not a fractal of the solar system. The core of the galaxy does not affect the sun the way that the sun affects the Earth. The sun affects the Earth in a very direct, magnetic and particle-based fashion. The core of the galaxy does no such thing to the sun. It's about 26,000 light years away. And the structure of the galactic core is nothing at all like the structure of the heliosphere. The heliosphere contains one star, the sun. That's the main source of magnetism and particle output for the entire heliosphere. The core of the galaxy is nothing like that at all, as every one of these stars has its own set of poloidal fields, set of toroidal fields, just like the sun does. And they're all interacting with each other in a massively, massively crazy and chaotic fashion. So anybody that tells you that the Milky Way galaxy is simply a fractal of the heliosphere is either completely ignorant or lying to you. So I ask you, the viewer, when does misrepresentation become fraud, folks? When does misrepresentation become fraud? Well, I can tell you, because I used to be the owner of an insurance company. And the difference between misrepresentation and fraud is quite simple. Fraud is misrepresentation when you know you're misrepresenting. In other words, if you're incorrect about something, you might not be committing fraud. But if you're intentionally misrepresenting material facts, you are committing fraud. So this brings us to our mission. One of the aspects of our mission is number 7, which is to not be ossified in our beliefs and treat those who are with love, respect, and inclusion to the scientific discussion. Why? Because being ossified in your beliefs is not science. Everybody doing actual science is out here trying to debunk our own theories. Because once your credibility is gone, folks, it's not coming back. If you want to read more about our mission, head to smashamash.com/forum/mission, and you can read all about it at smashamash.com/forum/mission. Next, we're going to pick a random number between 1 and 1031 because it coincides with an object at the Neil Gorell Swift X-ray Observatory, the Neil Gorell Swift Burst Alert Telescope. Today's random object is number 239. Now, we use a quantum number generator to get these numbers, and 239 is Quasar, a BL Lacertae object, which is a full-spectrum quasar. Quasar B0716 plus 714. And this is going to look like a plain old sphere when we look at it on the visual. Here it is in its X-ray output. You can see it's a pretty consistent X-ray source here. This is the 16-year chart of its X-ray transient outputs. And this is an object that you're looking right down the field of. So when you have a galaxy, folks, let me just do a quick drawing here. When you have a galaxy, let's say you have a spiral galaxy, if you're looking at it slightly off-center, it might look like this. You know, it's kind of compressed. You're looking at it sort of off-center, and the poloidal field of the galaxy is like this. If you're looking directly down this poloidal field, you will have a quasar or a blazar, or perhaps if you're not directly in the field, you'll have a Seyfert 1 galaxy or a Seyfert 2 galaxy. It all comes down to perspective, folks, and we prefer that our viewers have some. So here it is on the visual, and as you can see there, it looks just like a sphere. Now, this could be a spiral galaxy. We really don't know because the poloidal field and the brightness of it obscures the rest of the galaxy. Let's take a look at it in some different wavelengths here. Here it is in infrared. So there's a good view of that in infrared. You can see some additional features there. And we'll also see if it shows up on the multi-mirror project. Here it is on the XMM Newton, the multi-mirror X-ray project. And here it is on the Chandra. I'll bet it'll show up. And it doesn't show up. So we'll just close out the cosmology segment here on the XMM Newton. That is Galaxy, which is a quasar, B0716 plus 714. One last segment here. I thought I was closing it out, but we weren't. There was another thing to cover. So here's a quote from a phys.org article in today's Astronomy and Space section. Quote, energetic particles can arrive at Earth very quickly, within several minutes to a few hours, and we've talked about this before, how sometimes protons can show up in about a half an hour following a major coronal mass ejection. Energetic particles can arrive at Earth very quickly, within several minutes to a few hours, with these events lasting for days. Currently, we can only provide forecasts of these events as they are taking place, as it is highly challenging to predict these events before they occur. By understanding the sun's processes better, we can improve forecasts so that when a major solar storm hits, we have time to reduce risks. So this is an interesting article not only in that, but it also talks about the chemical structure. It also doesn't really hint about the fact that fusion is happening out in the corona and in the chromosphere, but in any case, it talks about some chemical concentrations in the solar corona. So perhaps have a read there, or maybe even have a read here. That's why we're allowing the article to scroll. But credit to phys.org. Once again, the Astronomy and Space section lead author, Dr. David Brooks, dropped me a line. We'll be more than happy to put you on the show. Their observations provided a tantalizing glimpse into where the material that produces solar energetic particles comes from in a few events from the last solar cycle. So again, perhaps consider having a read there on the phys.org's Astronomy and Space section. The article is entitled Source of Hazardous High Energy Particles Located in the Sun, and that's today's Cosmology segment. This one will be integrated into the daily space weather video. Again, we do have playlists, youtube.com/smAsho/playlists. You'll find a ton of videos there in the Cosmology segment playlist. And moving back into current data, here's a 3-day chart of the GOES X-ray flux, and we don't see any major flares. We saw just not quite a B-class flare right as I got out of bed today, actually right at the moment that my alarm went off once again. And shout out to the sun. Hey sun, thanks for supporting the channel, El Sol. And if you've got a comment directly for the sun, or if you think the sun's conscious, leave a comment below the video. No comment on whether I think the sun's conscious. That's for another video. We don't see any proton strikes there as measured by the GOES 16. There's a 3-day chart of 3 different voltages, 10, 50, and 100 mega electron volts, or 100 million electron volts if you prefer lots of decimals. Looking at the real-time solar wind, we still see an elevated solar wind from the coronal hole wind stream, and we're only 2 days away from another one. Anyway, current conditions are solar wind density around 5.5 protons per cubic centimeter. Solar wind speed declining steadily over the past 24 hours, now down to 517 kilometers per second, which is still like 1,000,000 miles per hour if you're doing the conversion. KP index now down to 1. So we saw a total of 12 hours there. Those are 3-hour bars. A total of 12 hours there of geomagnetic storm conditions and 9 hours of geomagnetic unrest in the past 3 days as conditions calm down. Here's a geospace movie here. It's the magnetohydrodynamic pressure. It's 4 hours of data courtesy University of Michigan via the Space Weather Modeling Framework. And you should expect to see the pressure dropping off here slowly over the past 4 hours. No real surprise there. And we can use the real-time solar wind to forecast what the magnetosphere movie will look like, and vice versa, especially if we understand the physics. So here is the global geomagnetic perturbations here, ground magnetic perturbations, otherwise known as geospace delta B, so changes in the Earth's B field. And we see lots of pulses here coming out of places like the Pacific and Indian Ocean. And since we're living through a geomagnetic excursion right now, we show 4 hours of data daily on ground magnetic perturbations. Here's a GOES magnetometer. 3 days of data once again as measured by the GOES 16. We'll show you where it makes its measurements momentarily. And we see pretty spiky, sawtooth, non-smooth things happening here, and it's no surprise there is another coronal hole wind stream set to arrive in just 2 days. So there's lots of plasma in between Earth and Sun. Not a lot of plasma in the corona right now. We have 2 sunspots. The Earth is solidly in the North Pole current sheet. As you can see here, this is the top view ecliptic plane field plot. It's showing you the polarity of the heliospheric current sheet. So as the solar wind emerges from the corona and as the sun rotates, one of the solar polar fields is charging up that portion of the current sheet to its polarity. So currently we are in the green portion. That's the North Pole current sheet. And we may be back in the South Pole current sheet in a couple days here. We'll keep you posted. It's part of the reason why we make the videos. Here's a different view of essentially the same data. It shows you also the poloidal fields. It's the line of sight field plot. It also shows you the solar magnetogram. And you can see that coronal hole there just moving out of the Earth-facing area. Here's a better view of that. It's the line of sight coronal hole plot. This is showing you the sun's B field once again in blue. And you can see that North Pole-oriented coronal hole there. That is the one that will be providing the next coronal hole wind stream, which will be striking in about 2 days, according to NOAA forecasts. Next, the magnetic environment of the solar corona. Keep in mind, look at the date stamps there in the upper left. The date is a little bit old here. This is old data. We show this daily anyway, the sun's chaotic atmosphere, known as the corona. And let's start talking electrons. And here's a diagram of the Van Allen belts as well as altitudes of spacecraft in miles. Feel free to pause that if you have to. And here are the charging hazards. We see some over the southern Indian Ocean here, southern Africa, and northern Australia. They're all minor, only yellow. The electron flux has moved into warning levels as there are relativistic electrons moving at nearly the speed of light surrounding the planet. These are the electrons in the ionosphere layer at about 300 kilometers altitude measured by the GOES-16. That is 2 days going back into electron flux warning levels. I know we got to approximately 5 times the warning level, which is that red line there, that red dotted line that coincides with 1,000 pulse flux units. Here it is in context. It's the 1 year chart of the relativistic electron flux, and you can see wild swings here, and it's hurting the forecasting. Here's the forecasts, and you can see the yellow diamonds are the observations and the green squares are the forecast. I only forecast this one. I think I'm going to be able to get it right, folks. Not every time. So don't lose your you-know-what over the total electron content forecasts. In any case, NOAA is forecasting this to come up, and no forecast from me on this one. You'll have to watch the daily space weather videos to know what's going to be happening. So here's a visualization of the whole air column. This would be from about 12,000 miles where a GPS satellite would be located down to your handset. I'll let it play through a second time. This will show you where GPS errors are likely to occur. And this is actually not anomalous really at all here. Fairly normal and expected areas for the total electron content. And so here's where the GOES-16 makes its measurements. The GOES-16 endeavors to make its measurements right there, around 300 kilometers at the F ionosphere layer. And again, feel free to pause this for your convenience and reference. And here's a map of just the ionosphere. Ionosphere looking a little bit anomalous here. So we're seeing some rapid charge-ups over the Eastern Pacific. Some nighttime charge-ups indeed of the ionosphere, so we're seeing some anomalies here. Some rapid charge-ups and charge-downs over places like India and the Indian Ocean, as well as Africa. Let's bring up the latest image. That one is from 10:30 Universal Time. Next, we're going to move into the realm of meteorology. Here's nullschool.net's jet streams. And the northern hemisphere's jet streams are all over the place. You see those S-shaped bends. Extremely chaotic jet stream behavior right now. And we have like doubled up and tripled up jet streams there in the south. Chaotic jet stream continues, folks. Here is the eastern world's jet streams. And I would note the jet streams are blowing straight up backwards over the Indian Ocean. Those are pretty strong jet streams. They are blowing east to west. Not normal. You think it's normal? Ask a pilot. It's not. Here is the lightningmaps.org real-time lightning map. We show it daily. And after seeing a solid week-long lull in lightning, we see a more normal amount here. Main lightning here off the coast of Portugal and off the east coast of the U.S. Next, we're on windy.com's pressure maps. Here's where pressure cells are now. And here's where pressure cells are expected to be via the GFS forecast at 12 noon tomorrow. If you want the Euro forecast for pressure, well, there it is. And there's even the icon forecast for pressure at 12 noon, and that's 12 noon Eastern Time. I know we talk most times in Universal. Moving on. Here's a map of the cloud layer over the U.S. We use the shortwave radiation map, 3.9 nanometers, on the NASA GOES interactive weather satellites. Strong low pressure system looks like it's developing there over central Utah. You can see a counterclockwise rotation emerging. Lots of low clouds over the Gulf of Mexico and off the coast of the eastern U.S. Perhaps cosmic ray flux clouds. We won't cover cosmic rays today, perhaps in a later video. Maybe tomorrow Maybe tomorrow I'll learn how to speak the English language and we'll cover cosmic rays. Here's the water vapor map. And the U.S. mostly fairly homogeneous here, or dry. So those darker areas on the water vapor map, those are just average moisture. The blue areas are high moisture, and the orange areas are dry regions. So there's a huge high pressure ridge here. This is all high pressure. And this is some low pressure over here. And we usually cover the data instead of models because, well, if you understand the physics, you can do real meteorology. And if you don't, not. Here's a U.S. Doppler radar map. And you can see some mixed precipitation there, centered around the four corners. The four-way border between Utah, Colorado, Arizona, and New Mexico. Some pretty heavy snow there in New York as well. Don't worry, folks, it's not COVID. And thanks, Smash Team, for tuning in. And thanks to the most important members of the Smash Team, our patrons, the true source of funding for the content. By the way, we lost 10 subscribers yesterday on YouTube because reasons. And we make just this side of nothing by making videos on YouTube. And so once again, the true source of funding for the content is our patrons. So please consider becoming a patron. It helps us out a lot and makes it more likely that we'll be able to complete our 2021 goals, like accountability, and keep these videos free and publicly visible. If you refuse to send us a couple bucks per month and open up your cobweb-encrusted wallet, please press like and subscribe and share the videos on your social media. Check out our playlists. We've got lots and lots of content, approaching 600 daily space weather videos just in that playlist. YouTube.com/smashamash. Tell your friends, your foes, your science noobs, and your science pros. Today's bonus features are the solar intensitygram to show you close-ups of those two sunspots, and they've degraded as I made the video today. That's actually shrunk since I did show prep. That's 2806. Here's 2807, which also shrunk a little bit. Here are the magnetic fields. There's 2806. Here's 2807. Looking pretty weak. And we've got some more bonus features here, close-ups of the southern hemisphere to close things out. So here's 94 angstroms. Great view of those two latest sunspots, 2806 and 2807. And we've got actually 4 wavelengths here. Here's 131 angstroms. And 94 and 131, those are both iron emission spectra. In other words, very, very hot iron gas that does not have all of its electrons. Here's 304 angstroms, ionized helium. And this is the best wavelength at showing filaments. Great view of those two sunspots there. Here's 193 angstroms. Actually, we've got 5 wavelengths because I know we've got 171 here at the end. There's 193. You also have a good view of that coronal hole there, now stretching beyond the solar equator. As the solar polar field reversal continues, we'll be covering it daily here at the Daily Space Weather. Last but not least, here's 171 angstroms. Thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics, don't drink it. If you do drink, don't drive. And since it'll never be now again, may that solar wind be at your back, and may that nonsense be absent from your YouTube subscriptions.